In this video, we're going to discuss polynomial synthetic division, or just synthetic division. So if you've been following my videos on long division, or you've just been doing some long division, I'm here to tell you that this is the coolest thing you could learn because it's going to save us so much time and stress because it's hard to mess up and it's easy to do, especially compared to long division, which, let's face it, is just long. And it's a lot of writing, you know, hand cramps and whatnot. So synthetic division, I think we should probably start with this, okay? The fact of the matter is, when we discuss synthetic division, I think you need to write this if you're taking notes in your notes. It only works for linear factors, okay? Or linear divisors. Maybe I should put that away, okay? So the fact of the matter is, we could not divide with synthetic division if we were dividing by something like x plus 1. That's a linear factor, a linear divisor. Or divide by x minus pi. Okay, that is a linear factor. You know, like these are good, these are acceptable. Something that would not be acceptable, we could not divide by something like x squared minus 1. It just can't happen. Like this is no good. We would have to use long division on this, and I know that just makes you sad, but I don't know if you heard me. It only works for linear divisors. So like, let's get that straight. Okay. So going ahead, let's go ahead and get started. The fact is, if we're talking about linear divisors, excuse me, linear divisors or linear factors, hopefully a factor. It could be, it could not be a factor. The bottom line is this. We said in the past, if say some number k, x minus k is a factor, if x minus k is a factor, then we could say x equals k is a 0. Now I mention this because with synthetic division, let's say I wanted to divide a polynomial by x minus k, and that's my factor. The bottom line is, when we do this, we actually have to use the reverse of k, or we would use positive k as opposed to negative k. So let's go ahead and start, why not, with a polynomial here. We'll actually, I did make a good one up, and the reason why I made this up is because I wanted to have some obvious zeros. So we'll go take a look at it. Actually, it's right here. So this polynomial, it's kind of hard to see up here. It's x cubed plus 5x squared plus 2x minus 8. So x cubed, let me write that down. X cubed plus 5x squared, x cubed plus 5x squared, please forgive me, plus 2x minus 8, plus 2x minus 8. And so this is our function here, f of x. And let's say I wanted to divide out a factor. Well, the good news is, a lot of us have graphing calculators, and we can easily see some zeros on this. So for example, I happen to know that -4 is a 0, -2 is a 0, and 1 is a 0. So what I was saying previously is like, hey, if 1 is a 0, that is like x equals 1 is a 0, then this implies that x minus 1 is a factor, okay? So really, if I were to say, interpret this, I want to divide this by x minus 1, which we know should go in evenly. So let's go ahead and get started. What does synthetic division look like? Well, first of all, for starters, we don't use a division bar. It's kind of like an upside down division bar. And all we're going to do is insert the coefficients, okay? The coefficients of all of our places up here. So like our x cubed place, or our x squared place, is 5, a 2, a -8 here. We're going to take those, and that's what's going to go in here in our, typically what would have been our dividend bar. But we're just going to put in the coefficients. And as far as out here goes, okay, so here's the important thing. If I am asking you to divide this by x minus 1, what I really am in reality asking you to do and put on the outside is going to be this number here. What you would get if you solve this factor while setting it equal to 0. So, in other words, if you're using x minus 1, okay, set that equal to 0, you get x equals 1. We're just going to put a 1 out here. It's just the way it is, okay? It is the way it is. We'll go through an awkward factor sometime, like a 2x plus 1. Of course, if you set that equal to 0, you get x equals -1/2. And that's what we put on the outside of synthetic division. But hey, we're not doing that. So this being said, here are the steps of synthetic division. I hope you're paying careful attention. The first step is this. Always just carry down that leading coefficient or that leading digit. And what we're going to do is we're going to take this and we're going to multiply it by the number on the outside here. So we'd say 1 times 1, I get 1. That's what's going to go up here, okay? So I'd say 1. Now, that being placed there, what we're going to do now is we're actually going to take this 5 and add it to what we just got here. And that comes down here and gives us of course, a 6. So now with this 6, we're going to take it times our 1 up here. 1 times 6 is 6. So we get now 2 plus 6 is 8. And so now we're going to take this 8 times our leading digit out here. We say 8 times 1 is 8. Okay, so we get 8. We're going to add this negative 8 plus our positive 8, and we get 0. So how is this division at all? Well, here's how this works. This trailing digit out here, this always represents our remainder. And you'll notice we didn't get a remainder this time. The reason why is because we divided something that was a factor. That is, it goes in evenly. We knew this. Okay, but this is our remainder. These spots now, respectively, going backwards, if this is like our remainder or constant spot, then we would say, okay, sorry, this is our remainder, that's r. Then we say this 8 here represents our constant, or our x to the 0. This 6 right here represents our x to the first spot. And we would just keep going back and filling in x squared. We don't have any x cubed. But what this means is, when we divided out x minus 1, what we have left over is, get this, 1x squared plus positive 6 x to the first plus 8 constants. Which, by the way, if you were to factor this, factors down into x plus 4 and x plus 2, which, hey, by the way, going back to look at my picture here, those were the other two factors because these are the other two zeros. So just to reinforce this, I would like to try this one more time. Let's say we divided by a different factor that we knew existed. Like, so if x equals negative 4 had been one of the original zeros, then x plus 4 is implied as being a factor. So let's do this one more time. Okay, so we're dropping in our coefficients, 1, 5, 2, negative 8. If x plus 4 is a factor, then x minus 4, equals negative 4 would have gone outside if we were dividing out x plus 4. So let's do this again. You carry down the leading digit, multiply it by our digit out front here, negative 4. So we get negative 4. So now we'll add. 5 plus negative 4 is 1. 1 times negative 4 is negative 4. 2 plus negative 4, we're adding now, okay, is negative 2. Negative 2 times this leading thing is positive 8. So negative 8 plus 8 is 0. So we would have seen, again, there is no remainder. No remainder. Okay. Also, we'd say this is our constant. This is our x to the first term that's in our quotient. This is our x squared. So we were left with 1x squared plus x minus 2. So even to take this a step further, if I said now factor your answer, because this is our answer right here, this is our quotient. This factors down into x plus 2, x minus 1, which, of course, that's our other two zeros, okay? Negative 2 and positive 1, if those are the factors. So synthetic division is just a really quick way of using your coefficients and your factor once you've solved it to get through this really quickly. We'll do more videos on this.